this video, I'll be presenting information from Chapter 6 of Human Anatomy and Physiology, 11th edition. This chapter focuses on bones and skeletal tissues. In particular, I'll be talking about development and growth of bone. So let's start with this definition, ossification. This is the process of bone tissue formation. It's also known as osteogenesis, and it begins about month 2 of development. It also continues postnatally, that means after birth, and it continues until early adulthood, so we think around age 25 in most people. But ossification can continue as remodeling and repair throughout the lifespan. So remodeling and repair are lifelong processes that involve ossification. So let's start with this developmental process. So first we have a type of ossification called endochondral ossification. This is one type of bone formation. What I hope you'll see is that most of this endochondral ossification is occurring prior to birth. So we have bone tissue formation through the replacement of hyaline cartilage. And the resulting structures are called endochondral bones. It turns out that most of our adult bones are actually endochondral. So let's just briefly look at what this process is. So in endochondral ossification, the center of ossification, so where it starts, is this primary ossification center. And this was hyaline cartilage, but as you can see in that primary ossification center, the hyaline cartilage is turning into bone tissue. So this first step is the formation of the bone collar. Next, 2 to 3 months of age, we're going to have cartilage calcification. So now all of a sudden the cartilage is hardening. We're getting those calcium mineral salts deposited within this growing tissue. From 4 to 9 months of development, still before birth, we have the formation of spongy bone. So that's now forming. We've got, you can see blood vessels coming out of this periosteal bud. So the periosteum is now forming blood vessels. And then finally, again, at 4 to 9 months, so right around the time of birth, we get the diaphysis elongating and the medullary cavity forming. So here's this cavity in the center. It's going to be filled, at least at that point in development, with red bone marrow, so being a source of red blood cells. And you can see lots of blood vessels going in and out. The epiphyses are starting to become a little more obvious, but this diaphysis is really getting a lot longer. And then finally, from birth to about that 25 years of age, we're going to start to see the epiphyses ossifying, so they're going to get harder and harder, and the bone is going to continue elongating. So this is all endochondral ossification. Remember, this is defined by bone tissue replacing hyaline cartilage. A second type of bone formation is called intramembranous ossification. And this is a type of bone formation that is found in flat bones. So one big difference between intramembranous and endochondral ossification is that while endochondral is bone formation from hyaline cartilage, intramembranous ossification is bone tissue formation from fibrous membrane. So again, we have multiple steps. It starts with ossification centers developing. So we can see here within that ossification center, we have osteoprogenitor cells, we have osteoblasts that are those bone matrix forming cells. They're all developing here within an ossification center in fibrous connective tissue. Next up, those developing cells start to secrete osteoid. So the osteoid is getting secreted by those osteoblasts, and it's going to start to calcify. So this starts to get hardened with those calcium mineral salts. Step 3, we now have, as ossification continues, those trabeculae start to form, and we get immature spongy bone and immature periosteum forming. And then finally, the compact bone is going to replace some of the immature spongy bone most adjacent to the periosteum. So here in purple, we can see the periosteum on either side, sandwiching together this layer of spongy bone, and now there is compact bone that is going to start to form along the edges of that bone, just under the periosteum. Okay, so now a third type of growth. This is something that actually continues to occur postnatally. This is called longitudinal growth. So this is the lengthening of long bones. And it's very similar to endochondral growth in that it is the replacement of hyaline cartilage with bone. However, the big difference is that this longitudinal growth only occurs at the epiphyseal plate. So that epiphyseal plate is the source of longitudinal growth. And eventually, again, probably sometime in your mid-20s, that epiphyseal plate is going to run out of hyaline cartilage, and it becomes the epiphyseal line, which is just sort of a reminder that that is where all that longitudinal growth was derived from. So here's some imaging that can take a closer look at that epiphyseal plate. And what you end up seeing here, we're looking at a bone, and we have the articular cartilage up at the top of that bone layering over the epiphysis. And we can still see a nice epiphyseal plate within that epiphysis. So when we look microscopically at that image, we can see up at the top of this image is closest again to the articular cartilage. And as you move down, this is going to move deeper into or toward the diaphysis. So you can see that there are all these different zones of this ossification process. So again, this is longitudinal growth happening. So first we have the cartilage. This is the resting zone. Now we get into a proliferation zone where those cartilage cells, the chondrocytes, are undergoing mitosis. They're dividing. Some of those cartilage cells are going to hypertrophy or get larger. Eventually, some of those start to secrete calcified minerals, and we get a matrix that's calcifying. And then finally, we get into this ossification zone where those cells have now given rise to osteocytes and osteoblasts that are creating more matrix and are allowing for the creation of what we call bone. So you can see here that basically it's a layered proposal. It goes from the articular surface into or toward the diaphysis of the bone, and that's how this longitudinal growth is happening at the microscopic level. In addition to longitudinal growth, we also have a second type of postnatal growth in bones, and this is appositional growth. So this is the increase in thickness of a bone. So in addition to getting longer, these long bones are also going to get thicker. So this is going to occur throughout life during remodeling of bones. And what you can end up seeing here is that basically this bone, left versus right, it has both gotten longer and it has actually gotten wider. So the widening of the bone is the appositional growth of the bone. We can regulate growth of bones in multiple different ways, but mainly here we can see it's regulated by hormones. This includes growth hormone. That's going to stimulate the epiphyseal plate in infancy and childhood and lead it to increased growth. Thyroid hormone is going to be a modulator, so it is going to affect the downstream effects of growth hormone. So this is going to ensure proper proportions. Thyroid hormone is going to make sure that growth hormone is active enough in all locations. And then finally, we have testosterone and estrogens, and they're going to promote adolescent growth spurts. And they're also going to lead to the end of growth, this longitudinal growth, by inducing epiphyseal plate closure. Just one thing to note is that any excesses or deficits of these hormones is going to end up leading to abnormal skeletal growth, or it can. So I'll leave you with a question. What is the source of endochondral ossification? Is it a primary ossification center, an epiphyseal plate, compact bone, articular cartilage, or a fibrous membrane.